Welcome back, guys. Today we're going to look at solving systems of equations using elimination. So this is the second type of algebraic method that we're going to use. So in the last lesson we looked at substitution, and today we're going to look at elimination. So let's jump right into it. The method elimination is often also referred to as addition or subtraction, and as we get into it you'll understand in a minute here. So if you ever hear about the method referred to as using addition or subtraction, that's the same as elimination. So addition and subtraction, same as elimination. So when we're doing elimination, the ultimate goal is to eliminate a variable or make it disappear. And then by eliminating one variable, we can solve for the other variable. And then once we know one variable, we can go back and solve for the other one. So the first thing we have to do when we're solving using elimination is we need to set up our equations so that the variables are lined up. So because it's referred to as addition and subtraction, we're going to be adding and subtracting our equations. So the first thing to do is line up your equations, and just like when we're adding and subtracting numbers, you can put your equation line below if you need to. Now, some steps when you look at them in a textbook will tell you that you have to put it in standard form or general form, standard form, ax plus by equals c. You don't have to do that. However, that's often what you're going to see me doing. You could have your x's on one side of the equation and your y's on the other, but the most common way to see it done is to line everything up using standard form. All right, so once we have our equations lined up, we have to figure out which variable we want to eliminate. Now, in this case, we have a 2x and a 3x and a negative 1y and a 2y. None of my variables look the same yet. So that means I'm going to have to make them look the same, and I'm going to have to do something to the equation to make them look the same. So I'm going to choose to eliminate my y's because that looks like the one that might be easier to eliminate. So I'm going to choose to eliminate y. Now, as we work through more examples, it'll become easier to see why I chose that variable. Now, if the coefficients of the chosen variable are not the same, we have to multiply one or both equations by a number so that the coefficients are the same. So if you notice up here, I've decided I want to get rid of y. I have a negative 1y and a 2y. Well, I want to make them so that my coefficients are the same. And I'm not really worried about the sign, I'm just worried about the number. So I've got my equation here, 2x minus y equals 4. And I have 3x plus 2y equals 3. Well, in order to make my coefficients the same, I'm going to have to multiply my top equation by 2. And it's important for you to know that that's the entire equation. So the equal sign is part of that. So I'm going to carry that 2 through, and that will give me a new equation. Now, by multiplying this equation by 2, I haven't actually changed the equation. I've just made it double. All right, so when I multiply this out, I'm going to have 2 times 2 is 4x. 2 times negative y is negative 2y. And 2 times 4 is 8. Very common mistake is for people to forget to multiply across the equal sign. Now, underneath, I haven't changed this equation. I've got 3x plus 2y equals 3. So I've finished that step there. Now we're on to step 4. Step 4 says to add or subtract the equations to eliminate the chosen variable. Well, I have a negative 2y and a positive 2y, so I'm going to have brackets around my last equation here. My signs are opposite, so if I want to make them disappear, in other words, I want to make them equal to 0, so if we're eliminating it, that means it's going to equal 0. I'm going to add them. So if you're remembering or trying to remember sort of a trick or a rule, if your signs are the same, so for your coefficients, if the signs are the same, you're going to be adding your equations. If there are opposite signs, if your signs are opposite, then you'll be subtracting your equation. And we'll look at both examples as we go through. All right, so 4 plus 3 is 7. So you got 7x. Negative 2y and positive 2y eliminates. It becomes 0y. And then 8 plus 3 equals 11. Now, if you want to put the plus 0y in there, you certainly can, but it doesn't change anything in my equation. All right, so I've got 7x equals 11. 7x equals 11. I can divide both sides by 7, and x will be 11 over 7. Now, just because we have a fraction doesn't change anything. So we've eliminated our variable, and we've actually already done step 5 now, solving for the remaining variable. Again, don't let fractions intimidate you. We're often going to see fractions in high school math. Now, once we have x equals 11 over 7, then we can substitute the variable into one of the original equations and solve for the other variable. Unlike substitution, we haven't actually subbed into either of the equations yet, so it doesn't matter which one you choose. I chose to sub into equation number 1. So we have 2x minus y equals 4. That's the equation number 1. And I'm going to sub the x value in. So that's going to give me 2 times 11 over 7 minus y equals 4. Well, 2 times 11 over 7 is 22 over 7 minus y equals 4. Rearranging that, I'm going to have y equals 22 over 7 minus 4. And so I have y equaling negative 6 over 7. So those are my answers. And then if you remember, we always write our solution in coordinate notation. So 11 over 7 and negative 6 over 7. Now, an important step that you don't want to forget at the end is to always verify your equations. And when you're verifying, that means you need to check both left side and right side. So if you're doing it algebraically, you need to check left side and right side. But it's also important that we check both equations. If we only check one equation and it works, we don't know if it's a solution until we've checked both equations. So we can check using LSRS, or you can graph it on your calculator. And so for this one here, I'm going to check it on my calculator. Because these are fractions, it's probably important that I've checked to see what those decimals are equivalent to. But I'm just going to check them on my calculator here. So I'm going to go to my y equals. My first equation is 2x minus y equals 4. So rearranging that, I'm going to have 2x minus 4. And the other equation is 3x plus 2y equals 3. So I'm going to have 3 take away 3x, and then all divided by 2. Again, when I'm rearranging to put it into my calculator, I'm not worried about what form it's in as long as it's been rearranged correctly to have y by itself. Second calc, 5, enter, enter, enter. And I get 1.57 and negative 0.86. Now, if I were to go into my calculator and check those decimals, they would be the same. So 11 over 7 is about 1.57, and negative 6 over 7 is about negative 0.9. So I know I'm correct, and I can move on. All right, so as we move on here, I'm going to be just going through a number of examples here, showing you all types that we might come across. Feel free to pause the video, try some of the examples on your own, and then work through it that way. All right, so let's start off easy here. When we want to solve using elimination, we're going to follow those same steps. We make sure that our equations are lined up. We want to make sure that our variables are lined up, top and bottom. This one's already done for us. I'm going to draw my equal sign underneath here. And I'm going to ask myself which variable I want to eliminate. Well, I have an x and a 3x, and a positive y and a negative y. Well, if my variables are the same, those are definitely the ones I want to eliminate. My signs are opposite, so I'm going to eliminate by adding. So x plus 3x is 4x. My positive y and negative y are going to disappear. And 5 plus 7 is 12. Now, to solve here, I'm going to divide both sides by 4. And that gives me x equals 3. Now, once I've done that, I want to just sub into one of these equations. It does not matter which one you sub into. I like to keep it simple, so I'm going to sub into the first equation because there's less algebra involved. So subbing in, I'm going to have 3 plus y equals 5. So y equals 5 minus 3 is 2. Now, again, you want to make sure to verify your answer, so I'll just do a quick review of left side, right side here. So we've got a left side, right side, and again, we have to check both equations. So LSRS, the first equation was x plus y on the left and 5 on the right, and the other one was 3x minus y on the left and 7 on the right. So x plus y using the solutions I came up with, 3 plus 2 is 5. This one works, LS equals RS. Now for this one here, I've got 3 times x, so 3 times 3 minus 2. 9 minus 2 is 7. This one also works, so I know that this is a solution. So my final answer is 3, 2. Again, we often write our solution in coordinate format. Okay, now going forward, I'm not going to be going through the verification. We did that with the last lesson. But again, it's important when you're doing your questions that you do verify your answers, and you can do that both graphically or using your algebraic LSRS charts. All right, so the next example here, we have 4x plus 12 equals negative 7y, and y plus 12 equals 4x. Well, the first thing we need to do is rearrange our equation so that everything lines up. And again, I'm going to use that standard form, but I wouldn't have to. I could have brought my y's over and had everything lined up differently. So for this one here, I'm going to have 4x plus 7y, because I'm going to bring the 7y over. Remember, when I switch sides, I switch signs. And I've got negative 12. Now for the second equation here, my 4x is going to come to the left, so I'm going to have a negative 4x plus y, and I'm moving the 12, so negative 12. Now I put my brackets around the second equation here, and I decide whether I'm adding or subtracting. Well, looking here, I've got two identical variables, so my 4x and my negative 4x, they're opposite signs, so I'm going to add my equation. All right, so 4 plus a negative 4, this is going to cancel. And I have 7y plus y gives me 8y. And a negative 12 plus a negative 12 is negative 24. Dividing by 8 on both sides leaves me with y equals negative 3. All right, now once I know what y is, I'm going to sub into my original equation. I'm choosing to sub into my second equation. My second equation was y plus 12 equals 4x. Again, I'm always choosing the one that looks like the least amount of work. Negative 3 plus 12 equals 4x. And negative 3 plus 12 is 9 equals 4x. We want x by itself, so we're going to divide by 4. So x equals 9 over 4, okay, which is about 2.25 if we were checking it on our calculator. So after we would verify this on our calculator and make sure it's the correct answer, we would write our final answer is negative 3. Oops, we want to make sure not to mix them up. X is 9 over 4, so 9 over 4, comma, negative 3. Common mistake there that I just made. Just make sure you're not mixing up your x's and your y's. All right, moving on. We have two more examples here. I've got 5x plus 2y equals 4 and x plus 2y equals 8. So again, I've checked to see that my variables are lined up, which they are. So I'm going to draw my equal sign. Now I have a 5x and a 1x. Those aren't the same, but I have a 2y and a 2y. Those are the same, so that's the variable I'm going to try to eliminate. I'm going to put brackets around my bottom equation. These are the same sign, so the way to eliminate is to subtract. So 5 take away 1 is 4x, and 4 minus 8 is negative 4. To get x by itself, I'm going to divide by 4 on both sides, and that's going to give me x equals negative 1. And then subbing in here, it looks like the second equation might be a little quicker. Again, it does not matter which one you sub into, but I've got x plus 2y equals 8. I'm going to sub in my negative 1 plus 2y equals 8. Simplifying, I'm going to add 1 to both sides, so I'm going to have 2y equals 9. And dividing by 2, y equals 9 over 2, which would equate to 4.5. Again, I'm going to double check using my LSRS chart or using my graphing calculator, and my final answer will be negative 1, comma 9 over 2, or negative 1, comma 4.5 if you're asked for a decimal. Next example here, we've got 10x minus 5 equals 3y and 2x minus 3y equals 1. So the first thing I notice is that my variables are not lined up, so I'm going to rearrange these. Now this time I'm going to show you that it doesn't matter how I rearrange, I'm still going to get the same answer. So I'm not going to use standard form here. I'm actually going to put my y's on the right-hand side of the equation. and you'll notice I still get the same answer. So 10x minus 5 equals 3y. I'm not going to rearrange that one. The other one, I'm going to have 2x. I'm going to bring the 1 over, so minus 1 equals 3y. So order doesn't matter, it just matters that my variables are lined up. Now if I look here, I have a 3y and a 3y. They're the same sign, so I'm going to subtract. So 10 minus 2 is 8x. Negative 5 minus a negative 1. So that's important. Sometimes people, when they're subtracting, they'll actually change the signs to help them not make mistakes. But we've got a negative 5 minus a negative 1, or negative 5 plus 1 becomes negative 4. And a 3 minus 3 is just 0. All right, rearranging, we're going to have 8x equals 4. Divide by 8, divide by 8, x equals 1/2. Now, if you had tried using standard form, you would still get the same answer. In fact, when I was doing my notes earlier, that's exactly what I did, is I used standard form, and I'm still getting the same answer. Now, once I have that one, I'm going to sub into my original. I just happen to know that 2 and 1/2 is going to cancel out to give me 1, so I'm going to choose to use the second equation. But again, you could use either and still get the same answer. So 2x minus 3y equals 1. Subbing in, I have 2 times 1/2 minus 3y equals 1. 2 times 1/2 is just 1. So 1 minus 3y equals 1. Subtracting, I'm going to have 1 minus 1 equaling 0. So I'm subtracting 1 from both sides. And I have negative 3y equals 0. And dividing by negative 3, I have y equals 0. So again, you would verify your answers, but your final solution will be 1/2, 0. All right, now what would happen if we don't have any variables that look the same? So if you notice here, we've got 7x, a minus 3y, negative 5, 3x, 2y, and 11. So no matter what I multiply by one equation, I still can't get things to look the same. Sometimes we have to multiply by both equations. So I'm going to choose to eliminate my y's. 7 and 3 I could eliminate as well, but I'm going to eliminate y's because I know right off the bat that the lowest common multiple of 2 and 3 is 6. So in order to make this first equation equal to 6, I'm going to have to multiply, or to make that y variable equal to 6, I'm going to have to multiply the entire equation by 2. Whereas for the second equation, if I want the y to be a 6, I'm going to have to multiply the entire equation by 3. So after I've got that figured out, I'm going to write out my new equations. 2 times 7x, remember we're multiplying through all three terms. 2 times 7x is 14x, minus 6y equals negative 10. And multiplying through the second term, I've got 3 times 3x is 9x, plus 6y equals 33. Now my signs are opposite. I've got a negative 6y and a positive 6y. So I'm going to draw brackets around my second equation, and I'm going to put a plus sign. So adding these up, 14 plus 9 is 23. So I've got 23x. Negative 6 and a positive 6 are going to cancel. And negative 10 plus 33 is positive 23. So dividing by 23 on both sides, I end up with x equals 1. Again, you're going to choose which equation to sub into. I chose to sub into the second one. So I'm going to have 3 times 1 plus 2y equals 11. So 3 plus 2y equals 11. 11 take away 3 is 8. So I'm going to have 2y equals 8. Divide by 2. And y equals 4. Again, you're going to write your final solution is 1, 4. Okay, so looking at this question here, I've got 4x plus 3y equals 9 and 3x plus 4y equals 12. Once again, I have nothing that looks the same, and I'm going to have to multiply by both equations to make something look equal. So this time I'm deciding to eliminate the x values. And so if I look at the 4 and the 3, the lowest common multiple of 4 and 3 is 12. So to get the top equation to be a 12, I'm going to multiply everything by 3. And to make the second equation equivalent to 12 for the x value, I'm going to multiply everything by 4. So draw my line, I'm going to rewrite my equations. 3 times 4x is 12x plus 9y equals 27. Again, make sure that you're carrying it through all three terms. And the second one here, we've got 12x plus 16y equals 48. Now, if you remember, if the signs are the same, we're going to subtract. So 12 minus 12 cancels out. And then I've got 9 minus 16, so negative 7y. And 27 minus 48 is negative 21. I'm going to divide by negative 7. And I have y equals 3. Again, once I have that, I'm going to sub into either equation. I chose to sub into the second one. So we're going to have 3 times x plus 4 times y, which is 3, equals 12. So 3x plus 12 equals 12. And subtracting 12 from both sides, that gives me 3x equals 0. And dividing by 3 top and bottom, or sorry, dividing by 3 on both sides, we have x equals 0. And so again, our final solution, remembering x goes first, is 0, 3. Okay, we're going to look at one last example, and this is to start getting us thinking about what's coming. In our next lesson, we're going to be looking at word problems, and you're going to actually be building your own word problems and then using those to create a system of equations, solving and identifying what those solutions represent. So this time I'm giving you the word problem, I'm giving you the systems of equations, but I want you to be able to figure out and identify what those actual numbers mean in the solution. So here's the scenario. It says, suppose that you bought supplies for a kid's birthday party. 3 rolls of streamers and 15 party hats cost $30. Later, you bought 2 rolls of streamers and 4 party hats for $11. The system of equations below represents the situation. I want you to identify what the variables represent and then solve the system of equations and explain what the solution represents. So if we look at our variables, we have an S and we have a P. And if we look at the first equation here, we have 3S plus 15P equals 30. So this 3, the 15, and the 30 must have come from somewhere in the question. So if we look up here, we have 3 rolls of streamers, 15 party hats cost $30. So if you notice here, we've got 3 rolls times S plus 15 party hats times P costs $30. So we're talking about a cost. Well, we know how many rolls of streamers we have. We know how many party hats we have. But in order to get a cost, what we're missing is the cost per item. So S is going to represent the cost per roll of streamer. And the party hat, or the P, is going to represent the cost per party hat. All right, now looking at the second equation here, we have 2S plus 4P equals 11. So looking at the question here, we must have a 2, a 4, and 11 in there. And if we notice 2 rolls of streamers, makes sense that the 2 would go with the S. 4 party hats, so making sense that the 4 would go with the P. And $11 is our cost. All right, so we're going to set up this equation and solve. Now looking at our variables, we don't have anything that's in common. So I'm going to decide to get rid of the S. I don't really like working with S variables. They look too much like 5s. So I'm going to multiply my entire equation by 2 because the lowest common multiple of 3 and 2 is 6. And I'm going to multiply my second equation by 3. So doing that, it doesn't matter which side I'm multiplying from as long as I carry everything through. 2 times 3s is 6s. 15p plus or times 2 is 30p. I said s and I wrote x. All right, let's try that again. So 6s plus 30p equals 60. And multiplying the second one through here, I have 6s plus 12p equals 33. It's so common for us to want to write x's all the time because that's the variable we're most commonly used to using. All right, once we have this all multiplied out, we have to put our equal sign. We're going to put brackets around that second equation, and then we're going to decide what we do with our terms. Well, I have 6s and 6s, so they're the same signs, so I'm going to subtract. So 6 minus 6 is 0. 30 minus 12 is 18. So I've got 18p. And 60 minus 33 is 27. So to get p by itself, we're going to divide by 18. And p equals 1.5. Now I'm going to just leave that as a decimal for now. So p equals 1.5. We're going to sub into another equation. So I'm choosing to sub into the second equation. You'll notice I often sub into the second equation. That's just a habit that I'm in. Again, it doesn't matter which equation you sub into. So we have 2 times s plus 4 times 1.5 equals 11. So 2s plus 4 times 1.5 is 6 equals 11. We're going to subtract 6 from both sides. Gives me 2s equals 5. Divide by 2. And we have s equals 2.5. So again, those are just numbers, but what's important is to look at what those numbers represent. Well, we've said that S stood for the dollars per roll and the P stood for the dollars per party hat. So our R value, we're going to say that our party hats, or so P, our P value is 1.5. So it's going to be $1.50 per party hat. And our S is going to represent $2.50 per streamer roll. All right, so make sure that you take a look back at that question again, especially before we get into word problems in our next lesson. But that's all I have for you today, guys. I hope you've had enough examples. Have a good day, and we'll see you soon.